My friends, welcome to this week's weekend special. For last couple of weeks, I have been working on the Model Mania. These models are really interesting and I'm going to say smart. They seem really simple, but there are some tricks in there. So I'm so happy that I'm doing this as part of our model weekend special. Today, in that sequence, I will be working on Model Mania 2010. This one has two phases. So the first one is building this Y shape kind of thing, and then second phase is to actually modify that shape to in a different way. So as always, these are SolidWorks property. It's part of their competition. I'm just following through, doing some practice over it. So with that, let's go ahead and get started on phase 1. Now on this phase 1, I see where I'll have to approach this from two directions, and that way I will be probably building it as a common intersection of these two extrudes. So I'll be building this model top down and front and back. Then we'll be doing the common intersection Boolean operation from here. So I'll be using part design workbench, and let's start with the top down sketch on XY plane. I'll do this real quick with a note that we just saw in the phase 2. We will have to make one of these part straight, so we will do our dimensions keeping that factor in our mind. So I am using polyline to draw these boundaries, and polyline gives the chance to go through straight line and arcs, that sort of kind of thing, by pressing M repeatedly on the keyboard. M stands for modes, I believe, I guess. And see where it says this line is going straight because it's tangential to that arc. I'm gonna keep it going that way and come back to make it a flat later on. It really makes it faster for this polyline to draw these outlines. All right, there is the outline. Let's go ahead and fix some of these lines. All of these will be horizontal, and with that we'll have to be again careful applying these constraints to make their transition smooth on the phase 2. I want to say this is radius 10. Maybe I want to fix this line first. So that's the symmetry. And then from this point to the end, this is radius 25. So I'm going to go ahead and do that. And towards the end, so the distance between these centers is 100, and at the end, the radius is 12. So between this point and that point, this length is 112. Very simple. Now that we fixed that point, we can see that there are 4 curvatures with radius 20. So I'm going to go ahead and make these two 20. And again, this line will be straightened later on. So I'm going to keep that separate and apply the constraints for the second time, although it's the same 20. Okay, and then this is 10, we got that, and this is 10. This is also 10. Keep make it equality. And what else? Now we have these two are equal to a length of 8, and then I'm going to say the distance between these two is 60. Obviously these two will be symmetric by the axis in this face. And finally we have 9 degrees of freedom, and most of them are like these internal ones. So this arc, it has these dimensions, needs to be fixed here, and we will be doing that with construction geometries. Let's go ahead and draw a couple lines here. While we are doing that, I'm going to go ahead and do that one here as well. We drew the lines. Now we make them tangential to the arc. There. We'll do the same thing on this one too. Now we can say this distance is 35, and this distance is, well, it's from here, 75. All right, and we can go ahead and make this parallel distance as 8. Okay, and make these two parallel, and make these two parallel. This height is 14, and we are getting close, I think. Okay, so we done applying all that we could do. Now the only thing left is to actually fix these arcs. So the distance is moving here and there. Those are the 2 degrees of freedom. What I want to do is I want to make these 2 points in the same vertical plane, right? And then make these 2 points in the same vertical plane. And that fixes everything. All right, on this one, I'm going to say sketch top down, and then I take it downward by a height of, let's say 25 radius of, that's 50. I would say 55. I'm just keeping some extra and then hitting it reversed. Or maybe I want to keep it symmetric. There. Now we want to draw this face on this side. So let's go ahead and place it on XZ plane. And on XZ plane, let's do some relocating of this image right there. Okay, as long as it's covering, we are fine, but we can make absolutely sure of that by making this part a little transparent and see that they are covering these areas. Let's bring back the opacity and hide that for now. Let's go ahead and draw another sketch on XZ plane. This time I'll be doing the same thing on this face, so I'll go quickly about drawing the outline. Okay, the outline is drawn. It's time to put some values in it. First of all, this will be on this axis, right? And then the distance between these two is the most obvious one, 100. Let's fix that. Okay, this radius is 18. and we'll come fix it in a minute. This radius is 25. Okay, and this is 6. This is 12. Pretty cool. And we go make these tangents round. Okay, that was easy. I do this at the same time while we are at it. All right. Now we make these two corners same radius, which is 5. And then how about I actually make these two symmetric by this axis? So that's actually putting it in the same vertical plane as well. I don't have this radius, but looks actually it is 8. So looks like this will go at this point. And then, so if this is 18, right? And the gap is 8, so it will be radius 18 plus 8. Right. Now this is moving. The only way to fix it, actually come here and make this parallel, and then say the distance between these two is 8. Okay, so that's taken care of. We may have to do the same thing here, but let's go ahead and make this determination right now. Do we have that? Doesn't look like we have it, but here's this 8 distance. We can make this distance. We'll have to calculate it, but we can do it real quick. So this would be the radius of this, which is 6 plus the gap is 8, and then the other radius is, it doesn't have, actually it says full R. So what does that mean? Okay, we'll come back to it. Maybe we go about this point method and say this point is on the both here, and we do the same thing. So okay, the distance between these two would be 6 plus 8. Okay, that did the trick. I think that's fair. Now only thing left is this part, which is not that complicated. First of all, we make this one a construction geometry and then make that angle 45, so we know where we are at. And then these three will be parallel to each other, and this will be orthogonal, so it's a right angle. Okay, we got all of that sorted out. Now this is length 10, we got that. And finally, between this point and that point, the distance is 40. We can say that actually gives the length of this line, which would be 40 minus the radius, which is 18. The same thing. All right, we did that. Now we have 3 degrees of freedom, and one of them is this moving, and maybe we may have to place this toward the coincident. And then how about we make this symmetric? All right, beautiful. That did the trick. We have this side sketch, front to back, and I want to extrude that for at least 60 millimeters. So let's go with 70 and make it symmetric by the axis. And so we got that, and we have the top down, we have front to back. And now we can go ahead and make an intersection between these two objects that will give us our phase 1. It's that simple. It is that simple. Okay, now we'll have to worry about these edges being radius 2 fillet, and I think that would be easy here. So let's go ahead, select this line and this, so that will cover the whole thing, and take this and this. Okay, that should do the trick. And say radius 2. That was easy. Let's go and see. Okay, we'll have to make that inner edge, so we'll have to select this one too. So double click on the fillet and select this line, and although it has 2 already, type 2 and hit enter. That will refresh the whole thing. Okay, phase 1 was really easy. It did take less time compared to the previous 2 models. I'm happy about that. Let's go take care of phase 2 then. Before that, I'm going to go ahead and save it right now. All right, we have it all saved up. Let's go ahead and take a look at the phase 2. So phase 2, what it says is we have the Y. Now on that upper leg or upper arm would be straight, and this angle, remember this radius 10 is still radius 10, so this is pushing back because this 60 diameter didn't change. I mean, no diameter change, no dimension change. Just make this edge straight, and looking at this image, which is virtually the same. So this front image is the same. So that says me this gap and this hole are the same location. So only thing I'll have to worry about is making this arm straight and pushing it downward. And we can do that easily by changing the top down sketch. All we have to do is take this and take that away and make it a straight line. Okay. And I will be taking the symmetric constraints off. Let's go ahead and delete this one too, and this one, and maybe, okay, if I delete that, actually this 8mm go away as well. So what if for now I'm just going to go ahead and make it a straight line and try to handle it delicately from there. We will just make it, I can make these two coincident. Okay, let's see if I can. Okay, there is the same point. I'm gonna go ahead and delete that one too, that constraint. So this is the constraint that puts these 2 points at the same vertical plane. I don't think we will be needing that, so let's go ahead and delete these two. Okay, as an experiment, I'm gonna go ahead and make these horizontal. Okay, that did. How about I make this one horizontal? All right, so I can push it down now. What I can do is I can make this horizontal altogether, and I think we got the overall what we needed. It's good that we applied these 2 dimensions on this side, that way we don't have to apply it. Now all we have to do is, actually I can probably take this off and make these 2 coincident, right? And maybe, tell you what, I can actually delete these 2 lines and make these 2 points coincident. And we have 3 degrees of freedom. Let's go ahead and fix those. We'll do the same thing on here. Actually delete this line and bring it all the way up here and make it a horizontal one. All right. And this is loose now, so let's go ahead and place these 2 on the same vertical plane. Try it again. and that is fixed, right? So now the fillet didn't work, so let's go ahead and delete the fillet. Okay, and it looks really weird. I know why. Let's hide the common for now and bring these two components back. See how this is now moved downward and this is there. What I can do is on this front to back, I can come to the data tab and take the symmetry off maybe. Okay, so that is pushing it downward, but it's not cutting the whole thing here. So we probably want to, on the reverse side, give it some 20. Okay, now it's going across. Now we can hide these two, bring the common back. That should work. Cool. We have our basic shape from the phase 2. I think that's it. Now let's go build that fillet. So select these two edges. And this, I think that should do. And a fillet of 2 millimeter is all we needed. Okay, that broke actually the model. Okay, let's try again. We have something here going on. Something's going on here. Here is this line. I think that's coming from. Okay, let's give it another try. And it did break again. So here is something going on. I don't know why, but this model is breaking because of something. Okay, let's go investigate again. Okay, here is this edge kind of breaking down. Okay, I don't think I can do anything about that, but this point, this vertex is creating this line, and that line is conflicting, and here it's showing up, creating all sort of mess. What if we skip that fillet and say do the rest of them? Okay, yeah, that worked. So it's that fillet, and I'm sure there are some trick that can be applied here to do a filleting right there. And at this point, I think it's not that of an important thing to do. So I'm gonna go ahead and skip that face. I know that actually it is some sort of inaccuracy, but let's ignore that. All right. With that, let's go ahead and proceed to see what else in phase 2 we have. So it says apply 500 Newton load at these 2 points and fix this point, and then do an FEM analysis. It says material AISI 1020. I'm not sure if we have it on the FreeCAD library, but we'll give it a check. And then it says calculate the factor of safety and maximum deflection of the part. I want to go to FEM workbench and start with our procedure with starting a container, analysis container, and add a solver to it, and then add a material to it. And in the materials, see if we can find AISI 1020. I don't think there is anything like that. How about a quick Google search? Low carbon, low tensile steel, AISI 1020 low carbon steel. And the only thing we'll be needing here is the maximum flexural stress, or like allowable stress. And okay, tensile strength yield, that's what we need, 294 MPa. And that's the value we'll be needing to actually do the factor of safety. So even though we don't have it, I don't think it's a problem. I'm going to go ahead and use steel. So I'm going to say any steel. And I'm going to say 2C10. Okay, cool. We got the material. And now we apply the fixed constraint in this face. And then we apply load on these two faces. I want to add this face and add 500 Newton. And direction wise, so this would be the direction downward. Okay, so that's one load, and I want to select another load on this face for another 500. Let's do the same thing with the direction. Okay, now we're for sure that there is 1000 total load applied. Okay, and now we go to the mesh and we will try with the end mesh with a low mesh size and see if it works. Looks like it did. And let's go ahead and start the solver. Okay, it says calculix execute error. So we don't have the result. Okay. I can try with Gmesh and keep it auto and then hit apply. The nmesh didn't work out for us, and I don't know why it happens. Okay, it says there is some warning. We still can see if it worked. We can go to the solver, write the INP file fairly quick, and then run calculix. See if it does the trick. It did. So although there was some warning, the analysis came through, and we can take a look at it now. I'm gonna go ahead and hide this one too, and let's go to the results tab. Does look like it did look like it worked, but apparently it did not. Okay, let's try Gmesh for element order first and hit apply. See if this works. And still there are some warning. Let's see if it comes through. All right, looks like it did the trick. No warning. I can go hide a couple of these things and double click on the CCX results. That will give us the values that we need. So we need the maximum displacement, which is 0.144 millimeter. Now this displacement actually is not reliable because we don't have the exact material in there. But if we had the material exactly as it was specified, we would have the exact value, but we know what to do if we had the material. And as expected, the maximum displacement will come to this far end, and we can see how it looks. So there will be some displacement in here too, but being this one as the farthest from the center of the load, this is bending too much. And so that's the displacement. And then stress, we can see the maximum stress is coming up here as the tensile strength, and then there are some stress in there and at that phase. So given this is an overall cantilever setup, but there is a hollow part, so the stress is showing up all the places that are not actually intuitively can be seen. And we have maximum stress of 115 MPa, so that stress is coming, I'm guessing, somewhere here. So where the minimum bending is the maximum stress. So this place is the minimum bending, minimum displacement with maximum stress. And as far as the factor of safety, we are having 115 MPa developed stress in there, and our maximum allowable stress, tensile strength, is 294. The ratio of these two is 294 divided by 115, so 2.55. That's a fairly good factor of safety. So I'm going to say for this material with this loading condition, that's a fairly good factor of safety. Out of this analysis, the only thing we were not able to do is the maximum displacement, which is like, I think we are in the same ballpark area. May not be the exact value, but we are in the same ballpark area. And then we have a factor of safety from this FEM analysis. Hopefully you like this process. I will look into more in this filleting issue. It's not the easiest thing to do in the FreeCAD in phases like this, but there are some ways that I probably don't know yet. So I'll look into that. Other than that, we achieved 95% of the goal out of this analysis. Thank you for watching. If you have any question, or if you know how to address the issues that we faced, please leave them below in the comment section. Thank you for that in advance. I will see you in the next video.